Okay, and that will include, you know, the questions that are asked, but most of the time you don't really hear the question very well through the recording. It certainly wouldn't be able to identify you. You know, if somebody was, I don't know, searching for you online or something like that, I'm sure they wouldn't be able to recognize your voice, okay, through that. And I will never call you by name when I'm recording. Okay, like if you put your hand up to answer a question, I'm just going to point at you. Okay, it also hides sometimes if I take a long time to learn people's names and it doesn't look as obvious. Right? So feel free to ask questions or answer questions, okay, that way. So every time I teach you something new, okay, we'll start out and there'll be kind of a title, okay, slide that'll have like the unit and lesson number. So most of the time it'll look like this. Okay, it'll say here's the lesson number with the title and the key points. That matches up with the notes package. Okay, the notes package will have the same lesson number and key points, so you can always match them up easily. Okay, those key points are important. Okay, those are the things you would definitely want to be watching out for as I go through the lesson. Those are the things that are going to show up on a quiz or a test. Okay, they're going to be the focus of what we do that day. Okay. So today's going to feel familiar, right? We're going to go over scalar quantities and vector quantities, which is one of the first things you learned in Science 10 physics. Okay, we're going to use V equals D over T, also something that you learned pretty much right away in Science 10 physics. Okay? All right, so in terms of what we're going over, okay, so we'll be looking at these two formulas. V equals D over T. Okay, which can also sometimes be written like this: final position minus initial position over time. What do the little arrows over the top mean? That it's a vector quantity. Okay, so this formula is calculating velocity by dividing displacement, which is a vector quantity, by time, which is a scalar quantity. Okay, its other version is final position minus initial position, both vector quantities, okay, divided by time. Right? The other version of that is the scalar version. Okay, where speed equals distance divided by time. All three of those are scalar quantities. All right, so quick review. Scalar quantities have only a measured value or magnitude. Okay? So when you tell someone, you know, how far it is to somewhere else, okay, you're telling them the distance, okay, that would be a scalar quantity, right? Like, for example, if I asked you, how far is it to Edmonton, what would you say? Just an estimate. Any idea? About 320 kilometers, okay, would be how far Edmonton was. How many people were thinking it's like 3.5 hours? Yeah. Okay, that's something we do completely wrong, okay, in North American society. When people ask us, hey, how far is it to that place? We tell them how long it takes to get there, okay? It's probably what they wanted because that's how we're trained, okay, in our society is when someone asks how far, we tell them how long, okay? What's the problem with that? Is it always 3.5 hours to Edmonton? Okay. Like, is it always 40 minutes to the airport? No. Okay, that's like ideal conditions it might be. Okay, but I guarantee you the airport is always around 60 kilometers from here. Okay, that's not going to change unless, you know, the continental crust rips open and there's a gaping hole between here and there. Okay, it's always going to be about 60 kilometers. Okay? But the time it takes to get there is dependent on how far it is, which never changes, and how fast I can go, which is variable. Right? If I get in a traffic jam, it could be a lot longer. Okay? I mean, I have gotten to Edmonton in as little as 2 hours and 45 minutes. I was not driving. My crazy friend was. Okay? And 9 hours. Okay? You get in a snowstorm and they close the road, you got to take all the back roads back with all the traffic that's normally on a 4-lane divided highway. It takes a lot longer. Okay? So when in physics, if I say how far it is, I'm going to want a number in meters or kilometers or something like that. I'm not going to want a time. Okay? Little things we have to get our minds around. Okay, so scalar quantities are just measured values with a magnitude. So distance, okay, it's this many kilometers. Okay, mass, okay, the mass of that object is 50 kilograms. Okay, we don't give a direction for mass. It's just how much matter there is in that particular object. Okay, that's another one that we get wrong in North American society, right? We ask people how much they weigh, and they tell us their mass. Okay? I mean, if someone asks you how much you weigh, you tell them a number in either pounds or kilograms. That measures mass. I love messing with people when they ask me that. Because first off, it's rude. Okay? And you shouldn't ask me how much I weigh. I might be sensitive about that. Okay? So when they ask me how much I weigh, I tell them 750 newtons. And then they usually laugh awkwardly and walk away, which is awesome because I'm an introvert by my nature anyway, and I probably didn't want to talk to them in the first place. Okay, but I also haven't lied. Okay, I've told them my weight, how much the force of gravity pulls on my mass in a downward direction. Weight is actually a vector quantity. Okay, it's a force directed downwards. Okay, which is much different than your weight, which is how much of you there is. Okay, how much matter do you contain? That's your mass. But that's what we tell people when they ask how much we weigh. Okay? If I went to the moon, would there still be just as much of me as there is here? My mass would be the same. What about my weight? I'll weigh less on the moon, right? Okay? So there's a difference there. There's a few things that you're going to learn in this course that we say wrong. Okay? For whatever reason, we just do. Okay? But we have to have them straight for physics. Okay, so scalar quantities, just a magnitude. Vector quantities have a magnitude and a direction. It's the difference between speed and velocity. Okay, I have never known anyone to get a velocity ticket. Okay, and if you get pulled over and you tell the police officer when they ask you how fast they were going, yeah, if you're asked how fast were you going, they want a speed. They are not asking how fast and in what direction were you going. If they have to ask you that, they probably suspect you of something other than speeding. Okay? Probably be followed by field sobriety tests on the side of the road. Okay? Because you were obviously then going the wrong direction in addition to speeding. Okay? But if you tell them that, and when they ask you how fast you were going, oh, I was going, 115 kilometers per hour at 13 degrees west of south. Nah, they're going to get suspicious of you because that's a weird way to answer that. Okay? And that's not what they wanted. You gave them your velocity. They wanted your speed. Okay? You never see a velocity limit sign on the side of the road. Okay, and then obviously defining velocity is a change in position. Okay, that's this. Okay, displacement is a change of position. When you divide that by time, you're telling me how quickly and in what direction are you changing your position. Okay, hopefully that all sounds familiar. Okay, from Science 10, because that's all stuff we would have gone over. Okay. Are vector quantities always better than scalar quantities? Like if you have a choice to use one or the other, is there one that's always better? Not always. Sometimes a scalar quantity is more fitting in a situation than a vector quantity. Okay? So like for example, if I'm telling you how to get to or how far away the airport is, okay? I don't need to tell you that it's north of here. You know where the airport is, okay? You just want to know how far you have to travel. I'm just going to tell you it's 60 kilometers, okay? You know to get on the road and go north, okay? I don't have to tell you it's 56 kilometers at 22 degrees east of north, okay? Is that going to help you get there if I tell you that? Not unless you have a helicopter, okay? Because there's no way you're traveling in a straight line 22 degrees east of north, 50 whatever kilometers from here to there. Okay? I don't know how you're going to get across 2 rivers and walking through people's homes, like literally through their walls. Like that would be a neat trick, right? Like you're not going to be able to do that. in that kind of a situation, a scalar description is more appropriate. Okay? Road signs, same thing, right? When you get on the highway here, it says Lethbridge 200 kilometers. It doesn't say 200 kilometers and then give you a compass direction. Follow the road, you'll get there. That's more appropriate. Okay? So sometimes scalar is good, sometimes vector is good, okay? Sometimes either one can work. Okay? But most of the time, one is going to be more appropriate for a situation than the other. But there's never a case where one is always better. Okay? All right. That makes sense, though, the difference scalar, vector, ringing a bell? Okay, so a vector quantity can be more descriptive, okay, because it's obviously going to have the measured value, but it's also going to have the direction. It's more descriptive. Is it more accurate? Is a vector quantity always more accurate than a scalar quantity? Okay, let me write this and you tell me. Okay, 40.16 kilometers, top value. That's a scalar quantity. I didn't give a direction with that. Below that, I have 40 kilometers at 16 degrees west of south. Which one's more accurate? How many people say top one's more accurate? You have to vote. How many people say bottom one's more accurate? Okay. Just because the bottom one has more information doesn't make it more accurate. And I played a trick on you there, okay, because that's usually what people say. Right? They look at this and they go, you wrote more. That means it's more accurate. But it's not. This is actually the more accurate number. This number here, 40 kilometers, is accurate to plus or minus 1 kilometer. The last number I measured was this one. That's plus or minus 1 kilometer. This one is accurate to plus or minus 10 meters. Right? I have 2 more decimal places that I measure. That makes that one more accurate. Accuracy comes from how you measure, not from whether you add a direction or not. Okay, does the difference make sense? Okay, so a vector quantity is more descriptive. It gives you more information, but it isn't always more accurate. Accuracy comes from how did you measure it. Okay, this would be, I measured this distance with a stick that was 10 meters long. This one I measured the distance with a stick that was 1 kilometer long. That's kind of impractical, but that's what I did. Okay, I can only be accurate to plus or minus the unit I measured. Okay, that makes that one more accurate. Okay, everybody okay with that idea? Okay, that's going to lead us into significant digits. Okay, how many people know what I mean when I say significant digits? Okay, we'll learn about that. That has to do with measurement and accuracy. All right, if you were in my Science 10 class, we did a similar one to this, walking from your house to Walmart, okay? And comparing what a scalar description looks like versus a vector description of the same trip, okay? They're looking at this from 2 different points of view. It's the same trip, but when you ask 2 different people about it, and that's kind of what we're doing here, it ends up looking quite a bit different, or it can, okay? So if I want to walk from my house to Walmart, okay, I can't walk there in a straight line. I don't live right behind Walmart, okay? I have to walk, I have to make turns, I have to stay on roads or paths. There's no straight line route because I don't own a helicopter. And if I had enough money to own a helicopter, I sure as hell wouldn't shop at Wally World, okay? Aisles are full of crap all the time. The type A personality bothers me, okay? So the black line here would represent the path I would have to walk in order to get to Walmart. It's not a straight line. Okay? So let's say that when I get there, okay, when I get to Walmart, I have walked a distance of 4 kilometers. Okay? I can't give a direction on that, can I? I walked a whole bunch of different directions in order to get to Walmart, but in total I walked 4 kilometers. If I had my watch keeping track of my steps, it would tell me I'd walked 4 kilometers. Okay? So that has to be a scalar description. If I look at this from a vector point of view, the vector point of view only cares about how much and in what direction did I change my position. So where am I now in relation to where I started? Okay, that's what vector looks like. So the pink line, okay, is the vector description of this trip. Okay, that would be the displacement from my house to Walmart. Okay, so my displacement would be 2.8 kilometers at, let's say, 38 degrees south of east. Okay, do those two descriptions look very different? But it's the same trip. They're both true. Okay? Vector and scalar look at things very differently. Okay? If you're a Star Wars fan, it's like this. Okay? Obi-Wan Kenobi told Luke Skywalker that Darth Vader betrayed and murdered his father. But we also find out that Darth Vader is Luke's father. They're both true from a certain point of view. Okay? When Anakin Skywalker, who was Luke's father, became Darth Vader, he betrayed and murdered the good man who was Anakin Skywalker. From a certain point of view, that's true. Okay? Darth Vader was no longer Anakin Skywalker. But he was still Luke's father. Two different points of view, same story. Okay? That's why police investigations are so difficult. You get two people telling about the same event, they tell it very different. Okay? That's what's going on here. Okay? It's the same trip, just looked at from two different perspectives. Okay, so both of these things are true. When I get to Walmart, both of these are true. I've walked 4 kilometers, and I am now in a straight line, 2.8 kilometers, 38 degrees. Sorry, I said south of east. That should be north of west. I get that upside down. From my house. Okay, both of those are true. Let's say that walking there took me a half an hour. How fast did I walk? When I ask how fast did I walk, am I asking for speed or velocity? Speed. How fast? I didn't ask direction, I just said how fast did I walk. Okay, so if I want to calculate how fast I walked, okay, then I use the formula for speed. V equals D over T. Okay, so that'll be 4.0 kilometers divided by 0.5 hours. Okay, that's 8 kilometers per hour. Right? I mean, if I kept walking, I'd have walked 8 kilometers an hour. If I walked 4.5, right? Everyone okay with that? Okay, so that's my speed. I used my distance and my time to get it. What if I want to calculate my velocity? What do I do different?
You use your displacement.
I use the displacement instead. Okay, so I go V with the arrow over top equals D with the arrow over top over time. Time's the same. Okay, regardless of what perspective, the only thing the two stories have in common is it was a half an hour. Okay, that's how long it took me to displace myself 2.8 kilometers at 38 degrees north of west. Okay, it took me a half an hour to do that. Okay, so my velocity ends up being 5.6 kilometers per hour at 38 degrees north of west. Okay, the vector goes along. Anytime you're using this formula, your velocity vector will always be the same as your displacement vector, right? If I drive 100 kilometers per hour north, is there any way for me to be displaced east? They have to have the same vector, right? So velocity and displacement are always going to have the same direction. Okay, does that seem a bit familiar? Okay, here's where it gets weird. When I get to Walmart, because I'm old, you know, my mind's not as sharp as it used to be, I realize I've forgotten all methods of payment. I'm not going to walk around Walmart for the fun of it, so I turn around and I walk exactly the same route home. How far have I walked? It's 4 kilometers to Walmart. I walked the same path back. How far did I walk? 8 kilometers. Okay? So my total distance is now 8 kilometers. I walked and it took me a half an hour to go home. Is my speed still 8 kilometers per hour? Yeah, because that's exactly what I did. I walked 8 kilometers in 1 hour. So my speed would be 8 kilometers per hour. Okay, that part probably makes sense. When I get home, what's my displacement? Right. When I get home, my displacement is 0. Because displacement talks about how much you've changed your position. How much have you displaced yourself from your starting position? Well, if I started at home, and I ended at home, I haven't displaced myself. I went right back to where I started. I walked 8 kilometers in doing it, but from a vector perspective, I accomplished nothing. I ended up back where I started. So if my displacement was 0, what was my velocity over the whole trip? Zero. Okay? When I want to calculate velocity, I go displacement divided by time. That's 0 divided by 1 hour. Last time I checked, 0 divided by anything is 0. Okay? That's where vector and scalar really start to have major differences. Okay? So, on your car, you have a little thing called an odometer. It tells you how far you've driven the car. Okay? Do you want that to give you a scalar description or a vector description? Yeah. I mean, well, actually, if you want to resell it, you probably want it to read a vector. Because every time you came home, it would read what? Well, it'll read how far it was from the dealership you bought it at to your house. Every time you go back for an oil change, it will read 0. So when you trade it in, go back to the same dealer, it'll have no miles on it. Okay? Because your displacement from where it started driving is 0. Okay? That's not useful. Okay? So we would want that to have a scalar number, just distance. How far have you driven this car? Okay? Because it's possible, if it was reading vectors, I could have driven it 250,000 kilometers, but once I get it back to the dealer, it says it's brand new. Okay? Which is obviously not true, and also not useful. Okay? Everyone follow me there? Okay? Sometimes scalar is good, sometimes vector is good. Okay? In this case, for an odometer on a car, we would want that to measure distance, not displacement. Okay, ringing a bell there. All right. I'm going to give you about a 2-minute break here, okay, before we move on to the next things. Put your pencils down, take a little breath, talk to each other for a minute. Okay. I will recognize that reading a physical paper map is like a kind of a dead skill. Okay, how many of you have ever used an actual paper map in your life? Okay, it's usually like 1 or 2 people these days. Okay, because, well, you guys don't need them, right? Like you just plug in where you want to go on your phone and it tells you when to turn, which is awesome. Okay, but it also means that we kind of lose a little bit of our ability to look at a physical map and understand what's on there. Okay, let's say that I am here at Seldom Inn Campground. Okay, that's what the place is called. Just outside of Seldom Inn Campground is a sign, okay? And that sign says, Okay, Snake Indian Falls Campground, that would be right here, okay, 27 kilometers. What is it giving me? Distance or displacement? Distance. What is it assuming I'm going to do? Follow the trip, because that's the most safe and logical way to get from 1 to 2, okay, is to go this way, okay? And then I would arrive safely, because every time I go over a river, there'll be a bridge, okay? You know, the trees will be cleared and things like that, right? I stay on a trail, that makes more sense, okay? There is definitely not a sign, okay, outside of Selden Campground that says Snake Indian Falls Campground, okay? 18.9 kilometers at 40 degrees west of north. Okay, that might actually be accurate. I'm kind of guessing, but let's just say that that's accurate. Because why would I go that way? I certainly wouldn't go that way on foot. Okay, I'm flying a rescue helicopter. That's a number I want. Okay, that would be more appropriate for me. Okay, to just fly along that straight line and get there faster. That's the huge advantage of a helicopter. Okay, it's flying in a straight line and not having to worry about what's on the ground. Okay, so there are going to be times, okay, in this course where you're reading through a question and it's talking about maybe an airplane or a boat. Okay, those are things that can generally travel more in straight lines. Okay, vectors are going to be more appropriate when we're talking about those kind of situations. If we're talking about a car on the ground or a person walking, okay, something like that, then we're probably going to have to take into account we can't walk in a straight line. Agreed? Okay. There's a lot of context-based problem solving in physics, okay? More so than there ever has been. So what you're going to get a lot more of in Physics 20 than you got in Science 10 is going to be, well, for lack of a better word, stories to read. Okay? You're going to have a question that asks about this trip, but it's going to give you a whole bunch of, well, useless or extraneous information about the trip. Okay? It may be able to tell you what kind of trees you're going to see as you walk along this path that is 27 kilometers, okay, long from this point. Okay? And since most people walk at an average speed of 3 kilometers per hour while looking at certain types of rocks, like it's going to bring in all this stuff that's not important while simultaneously throwing out numbers that you might want to solve the problem. Okay? The reason we do that is because more and more on the diploma exam, we're seeing the same thing. Okay? We're seeing people writing stories that are related to problems that we have to solve. Okay? So what we have to do now is say, we have to build the skill of being able to read this boring story, because it's always a boring story, okay, and pick out the information that we need. Okay? Is this story talking about a vector situation? Is it talking about a scalar situation? Does it want me to do both? What information, what numbers is it giving me? Okay? That's going to be a skill that we'll work on throughout this course. Okay? Does that sort of make sense? Okay? Because we saw actually about 3 years ago in the diploma exam, literally, the students had to read a full page of text, and then they had to answer one question. Okay? And in that page of text, they probably only needed 3 sentences to solve the question. Okay? I don't know why they're choosing to do that, okay? But that's the direction they're moving in. So, yeah, like reading comp, but in physics, except you don't have to interpret it. Okay? Like it's not like, well, what is the writer trying to convey? Numbers! We want the numbers out of this problem, not like differences of opinion. Okay? All right. Okay, so just talking about displacement and distance, okay, and velocity and speed. They have similar relationships. They are the scalar measurement or vector measurement of the same trip. Okay, so when we talked about the trip from your house to Walmart, okay, we looked at that from both perspectives, vector and scalar. The displacement number is almost always the smaller number unless they're equal. They can be equal if you actually walk in a straight line. Okay, so it's always going to be the smaller number, but it's also always going to have a direction on it if it's displacement or velocity. Okay, And then we talked about if we traveled the same route home, that now our displacement would be 0 because now our change in position is 0. And that's where this formula that you used in Science 10 comes into play. Okay? Velocity is your change in position, so final position minus initial position divided by time. That is the other way to calculate displacement, is to subtract your, or find your change in position. We're going to come back to that a lot. Okay, it's not always going to be a subtraction operation. Sometimes it's going to be, okay, I need to draw a straight line and get how long it is and what direction it's going to get my change in displacement, but we're going to, or my change in position, sorry. Okay, so we're going to use that quite a bit, that idea of displacement being a change in position. So if I come back to the place I started from, I haven't changed my position. I am back where I started. Everyone follow me there? Even though I could have walked all the way around the world if that was possible, if there weren't oceans in the way, okay? I get back to my house, my displacement's still 0, but I've walked, tens of thousands of kilometers, okay? So that's kind of an extreme example, but as long as everyone kind of gets that idea, okay? Okay, so this is just terminology, okay? It should already be familiar. I don't expect anyone needs to necessarily write it down. Okay, scalar quantities are any measure that has only a value or magnitude, so 40 kilometers, 5 days, okay? 250 kilograms, okay, whatever, those are scalar quantities. Okay, time. Time is scalar? What do we think? Okay, it is. But it's another one we treat like a vector quantity in the way we speak. Okay, a lot of people would say, "Oh yeah, Strathmore is only it's only 40 minutes west of here or east of here." Well, if you say it's 40 minutes east of here, have you just made time a vector quantity? Yeah, time doesn't flow east. Okay, I'm going to travel in an easterly direction for 40 minutes. Okay, but 40 minutes is a scalar quantity. Okay, because as far as we experience time, time only goes ahead, right? So it's a scalar quantity in our perception of it, okay? Okay, so distance, scalar quantity that measures how far an object has traveled, okay? Speed, scalar quantity that measures how far an object travels in a set time interval, which is why its units are things like meters per second or kilometers per hour, okay? Centimeters per year, if you're talking about how fast a glacier moves, okay? Things like that, okay? Vector quantities, any measured quantity that has both magnitude or value and direction. 40 kilometers forward, 3.2 kilometers, 18 degrees west of south, 750 newtons down, okay? All of those are vector quantities. Okay, so our examples for this unit anyway are going to be displacement and velocity. Acceleration is also a vector quantity when we get to it. Okay, so displacement is a vector quantity that measures how far and in what direction an object has traveled from its starting position. Notice that wasn't part of the definition for distance, right? It's your change in position, so it's where you started to where you end up. Okay? And then velocity is simply measuring the rate at which you change your position, or the rate at which you displace yourself. So it's also going to be meters per second or kilometers per hour, but it'll add on that direction after. Okay? Everybody good with that? Okay. Okay, I want you guys to write this example down. Okay, and then see if you can solve it. I'll give you a couple minutes. Anybody need more time on that? Good to go? All right, so we're starting here. Okay, so our initial position is 1.5 meters to the right of the Inukshuk. Okay, then we walk to the left, and our final position is 3.5 meters to the left, okay, of the Inukshuk. So can I calculate my displacement? Absolutely. Okay, displacement is my change in position. So if I take my final position and I subtract my initial position, I'll get my change in position. Okay, but I can't subtract left and right. What do I have to assign to left and right? Positive and negative. That's a skill we're going to need to use all the time. Okay, is assigning positive and negative values so we can turn words into mathematical values. Okay, so I'm going to make left negative, I'm going to make right positive, and I'm just going to put in here negative 3.5 meters, 3.5 meters left of the Inukshuk, minus positive 1.5 meters, or 1.5 meters to the right of the Inukshuk. Okay, so if I take negative 3.5 and I subtract another 1.5, that should make me even more negative. Okay, now, do I want to leave that answer as a negative? Josh, you're nodding your head no, you're right. What do I want to change it back to?
You want to change it back to left.
Exactly, okay? The question gave me right and left. My answer has to reflect the directions I was given. Okay, so my final answer here is that the displacement of that person is 5.0 meters to the left. Okay, now, that person walked in a straight line. How far did they walk? 5 meters. Okay? In this case, their displacement and their distance have the same magnitude because they walked in a straight line. They didn't change directions. Okay? So their distance here would simply be 5 meters. Okay? Everybody all right with how that worked? Not too tough, right? Okay. Anybody need that anymore? All right, I want you guys to try these ones here. I'll make them a little bit bigger so that it's a little easier to read. Okay, let's try 1 and 2 for now, just because I think I made it too big. Oh no, okay, you can try them all. I can fit them all in there. Okay, I'll give you a few minutes and then we'll go through number 1. We'll give you a few minutes, but if you can get all 3 done, get all 3 done. All right, so on number 1, okay, they want to know the sprinter's displacement from their initial position. So if they go 40 meters north and then 20 meters north, no, 100 meters north, it's all north. So I can make all of them positive and just do what with them? Add them together. Yeah, okay, pretty simple one, right? I just have to say it's 160 meters. What do I need to put on the end of that? 160 meters north. Yeah, that would be their total displacement for that one. Okay, all I'm doing is saying, okay, they went, well, I should probably make that a little shorter. Okay, they went 40 meters north, and then they went 20 meters north, and then they went 100 meters north. Okay, now the way I drew that is how we draw what we call vector diagrams, tail to head. Okay, I put the tail of the next vector onto the head of the first, and I draw them as arrows, and I just keep making them point whatever direction they're going. Okay, had the last one been 100 meters south, right, then I would have flipped it. And I would have put it there. Okay? If that last one was 100 meters south, then my total displacement at the end of this is actually gonna be 40 meters south, because I'm gonna go 40, positive 40, plus positive 20, plus negative 100. Well, that's gonna set you back, okay? So when we draw our vectors, this is how we do it, and it gives us a visual representation of what the math is going to tell me, okay? Kind of a way for us to check our work. Okay, how many people have done number 2? Okay, let's have a look at number 2. All right, so on number 2, okay, the player fakes out the defense by moving 0.75 meters to the right and then 3.5 meters to the left. All right, so all I'm going to do is just represent both of these in the same way. Okay, I'm just going to say that this is my initial position, and first I'm going to move 0.75 meters to the right, and then I'm going to move
Good morning,
3.5
everyone.
to the left.
Can we
I
please
find that
stand for the
difference?
praying of the Angelus?
Okay, we'll finish that up tomorrow.